Hello guys, uh, pause the video once and just try just try to get the solution for once, and then after proceed to the solution. I hope you tried it for once, and now I'm going with the solution. A rod of mass m equal to 10 kg is hinged at its midpoint on top of a pedestal of height 50 centimeters, and the pedestal mass is having 250 grams, which is nothing but we can take, I think, 1.4 kg. M equal to 1.4 1 by 4 kg. Okay, what I'm saying, 1.4 1 by 4 kg. And now the ends of the rod are connected to a ceiling with the help of two springs of equal relaxed length L naught equal to 40. Relaxed length of springs are 40 centimeters. 40 centimeters means 0.4 meters, which is 40 centimeters. Okay. Unequal force constants K1 and K2. They told that is unequal force constants they are having, and we don't know which one is what. Which K1 belongs to which spring and K2 belongs to which spring, but we can figure it out with the help of the theory. Of course, that's how we solve this question. In equilibrium, the rod stays at unknown angle from the horizontal, and the springs are vertical as shown in the figure. If the height of the ceiling above the floor h is 1.5 meters, find the force of the normal reaction between pedestal and the floor. And they're simply asking the normal reaction here. This normal reaction they're asking. This n equal to what they are asking. So to find that n, we have to solve the upper part. If we can, I think we can break this question into several parts. First of all, they told that it is in equilibrium. That means if we see from this part, this must be in rotational equilibrium, right? The distance must be equal from here if it is a, and this is also must be equal to a. So if we take force 1 here and force 2 here, F1 must be equal to F2. This is the condition, I think. Yes, this is the condition. F1 should be equal to F2 to balance the torque. So we don't know what is F1 and what is F2, and also we have to give that K1 and K2 to that respective springs. Let's say they told that the natural relaxed length is 40 centimeters. First of all, let's see how much, if it is compressed or elongated. We don't know. We don't even know the springs are compressed or elongated. Let's take this h as h equal to 1.5. They gave 1.5 meters, and this is somewhere around 0.5 meter. What somewhere around is 0.5 meters, 50 centimeters, 0.5 meter, and that means this total is 1 meter. That means this is elongated, so force is in this direction. That means this also force must be in this direction. That means both of the springs are elongated. So both of the springs are elongated. There will be two conditions. Both can be elongated, or both can be compressed. Okay, so otherwise the net torque won't be 0. There will be some torque, of course. Now this is compressed less. This is elongated less. Which one? This is less elongated. This is less elongated. This is more elongated. Since F1 is equal to F2, and compression is more, this compression is more, K should be less. The the coefficient of stiffness, the stiffness of the spring must be less. I hope you guys understood what I'm saying. I hope you understood what I'm saying. So if we take the same picture again here, what happened? Copy, and I'm pasting it here. Okay, so we understood that K1, this is equal to K1 and this is K2, but we don't know the compression. We don't know compression or elongation, how much it elongated. Let's see how much it elongated. We don't know, so we have to find the elongation. For that we can define a theta here, or we can define a x here, and we can find the compression elongations in both of the springs. And we should not forget that F1 equal to F2. If this is the rod, this is F1 and this is F2. Both must be equal, otherwise the torque won't be equal to 0. So let's write the full equations. So this is the total height h, and the spring, the length of the spring we wanted is y1, and this is the x1, and this is h. We have to take capital H equal to y1 plus x plus h. If we remove h minus x minus h is equal to y1. I am doing literally baby spoon feeding, like you can say whatever you want. Literally I am spoon feeding. We can just directly write. So the current length of the spring we got, the current what just happening? Current length of the spring is h minus x minus h. If you want to get the elongation, remove the natural length, that's the elongation. So if we remove h minus x minus h minus 0.4 in spring 1. Okay, let's see for the spring 2. For spring 2, okay, the total height is h, and if we take this is y2, and this length is x, and also we don't know from where to where it is. We just wanted to get somewhere. I'll show here. Let's take this as x, and the total is h. Okay, I hope you guys got what I mean. From here to here this is total is h. Now try how to get the y2 value. It's actually easy. It's not that tough. If you remove h minus small h, you'll get value till here. We want the value till here, so we got the value till here. H minus h, this is value of h minus h, but we want till here. Just add the x. This is the current length of spring 2. Elongation, same thing, just remove h minus h plus x into remove um, 0.4. This is the elongation. Okay, so let's say this as x2 and this is x1 as we saw before, and this is the rod. This is k1 x1 and k2 x2. We know k1 x1 must be equal to k2 x2, and let's keep the values here. K1 is nothing but 25 newtons as we saw before. X1 is equal to h minus h plus x minus 0.4 equal to 15 into h minus h, what, I'm sorry, it is h minus now it is perfect, plus x minus 0.4. We know the capital H value is equal to 1.5 meters, small h equal to 0.5 meters, and we just want the value of x. Let's solve for the value of x. 25 into capital H minus small h is equal to 1 minus x minus 0.4 equal to 15 into 1 minus 0.4 plus x. This is nothing but 25 into 0.6 minus x is equal to 15 into 0.6 plus x, and we all know how to solve this one. 5 3s are 15, 5 5s are 25, 5 6 are 3.0 minus 5x equal to 3x plus 3 6 are 1.8. so we can send this side and this side. 1.2 equal to 8x, and 4 3s are 12.3, 4 2s are 8. So if we cancel this one, 0.15, x equal to 0.15 meters means 15 centimeters. We don't even need that. If we keep the value in the k1 x1, k1 x1, this is f1, which is equal to f1, this is equal to f2. And if we get the f1 value, f1 and f2, since f1 and f2 are equal, if we get the f1 value, that is the value of f2. So let's see, 25 into h minus, we just have to keep the value of 15 here in this one, because this is equal to f1 and this is equal to f2, and also f1 equal to f2, and h minus h is nothing but 0.6 minus x, (25) into 0.6 minus x equal to 0.15 is equal to f1, which is equal to 25 into 0.45. Multiply this. How to multiply? 4, multiply it with 4 and divide it with 4. It will be 100 by 4 into 0.45, which is equal to 45 by 4 newtons, which is equal to f1, also equal to f2. So if we write the free body diagram for this one, there is f1 and there is f2. There is a normal force 1, and there is also mg acting downwards. And if we write the free body diagram for that one, if we write the equations, f1 plus f2 plus n1 equal to capital M into g. f1 we got how much, 45 by 4, and f2 also is equal to 45 by 4 plus 45 by 4 plus n1 equal to 10 into gravity is also equal to 10 into 10 100. It will be 90 by 4 plus n1 equal to 100. If we subtract this one, which is equal to 310 by 4 and which is equal to 155 by 2, also equal to 77.5 Newton. This is not the answer. Because they asked the value of the normal force here. I hope you got here. The n1 of the reaction of the action of the n1 will be acting downwards, and there will be n2 acting upwards, which they asked, and also there will be small m into g acting downwards. I'll just draw the free body diagram and I'll write the equations. You will understand. There is n1 acting downwards and there is small m into g acting downwards. There is capital N2 acting upwards from the down. And if I write the equation N2 equal to N1 plus m into g, small m into g, N1 is 77.5 plus small m is 1 by 4 kg into 10, gravity is 10 meter per second square. 4, this is 2.5. If we add both of them, it will be 80 newtons. And then the normal force 2 is equal to 80 newtons. This is the answer. I hope you got. Thank you.